Bismillahirrahmanirrahim. Assalamu alaikum. My name is Bushra and I am here again with another lecture of Chapter 7 Fundamental Principles of Organic Chemistry, second year. We were discussing about the hybridization of orbitals and the shapes of molecules. We have discussed about the Sp3 hybridization, Sp2 hybridization. Now we will discuss today lecture about the Sp hybridization. In Sp hybridization, the structure of alkyne can be explained by yet another mode of hybridization called Sp hybridization. In this line, it is saying that the alkyne which having the triple bond, carbon-carbon triple bond, the molecules in which the carbon-carbon having the triple bond, the alkyne, the hybridization of these molecules can be explained by another mode of hybridization which is called the Sp hybridization. In this type, 1,2s and 1,2p orbitals of the carbon atom mix together to give rise to two degenerate Sp hybridized atomic orbitals. Students, you remember that we were discussing about the electronic configuration of the carbon atom. Carbon has the atomic number of 6, so the ground state electronic configuration of carbon is 1s2, 2s2, 2px1, 2py1 and 2pz0. Whereas in the case of excited state electronic configuration of carbon, one of the 2s2 electron is promoted to 2pz0 orbital. So in this case, the electronic configuration of carbon atom becomes 1s2, 2s1, 2px1, 2py1, 2pz1. We have studied that in the Sp hybridization, 1s and 3p orbitals are mixed up to give rise to the Sp3 hybridization. In the case of Sp2, we have discussed the 2s and 2p orbitals mixed to give rise to Sp2 hybridization. Now in the Sp hybridization, only 2s and 2px mix up to give rise to Sp hybridization. The 2py and 2pz orbitals remain perpendicular to these two orbitals, hybrid orbitals, to give rise to two pi bonds. So in this case, it is saying that in this type, 1,2s and 1,2p orbitals of the carbon atom mix together to give rise to two degenerate Sp hybridized atomic orbitals, 1s and 1px. These two orbitals mix up to give rise to two degenerate Sp hybridized atomic orbitals. These orbitals have a linear shape. Students, I have discussed that in hybridization you have to mention the electronic configuration, ground state electronic configuration, excited state electronic configuration, and then you have to mention the shape and the bond angle of the orbitals. So in this case, the orbitals have a linear shape. This is the linear shape. These two Sp hybrid orbitals which are mixed up to give rise to two Sp hybridized atomic orbitals, one of the smaller lobe and one of the larger lobe. So for the convenience, we don't mention in the geometry the smaller lobe. So in this case, these two hybrid orbitals mix up to give rise to a linear shape. This is a linear shape and the bond angle is 180 degree. So the two unhybridized atomic orbitals 2py and 2pz are perpendicular to these Sp hybridized orbitals, as I mentioned earlier. The 2py and 2pz orbitals which do not participate in the hybridized formation, hybrid orbital formation, these orbitals remain perpendicular to the hybridized orbitals. So in the case of the ethyne molecule formation, when two Sp hybridized carbon atoms join together to form one sigma bond by Sp overlap. So students, you are seeing that in this case, this is the ethyne molecule and the linear shape of these molecules, this is showing that this is the sp hybridized orbital. This carbon atom, this carbon atom, and this carbon atom, the sp overlap, they form one single bond, and this sp hybrid orbitals, the other sp hybrid orbital of this carbon atom form an sps overlap with hydrogen atom, and this with sps overlap with another hydrogen atom, the second carbon atom. The two unhybridized orbitals remain perpendicular to these orbitals. This is showing that this is the orbitals which do not participate in the hybrid formation. So these orbitals remain perpendicular to the hybrid orbitals. So these orbitals overlap above and below to form the pi bond. So you can show that pi bond by this and this one, and you can show this just like this one. You have to mention these students by like this. This is one carbon atom and this is the another carbon atom. This is the sp hybrid orbital of each carbon atom. So one sp hybrid orbital of this carbon atom form the sp s overlap with hydrogen atom, and this with sps overlap with hydrogen atom. The two unhybridized orbitals, the py and pz, these orbitals overlap and form the you can show this just like that. Okay, now the two unhybridized p orbitals on a carbon atom will overlap separately with the p orbital of the other carbon atom to give two pi bonds, both perpendicular to the sigma framework of ethyne. The presence of a sigma and 2 pi bond between two carbon atoms is responsible for shortening the bond distance. So in ethyne molecule, one sigma bond and two pi bonds are present. So the bond bond distance is shortened in the ethyne molecule because of the presence of one sigma and two pi bonds. So this is all about the sp hybridization. We will come with another lecture of the chapter 7 in another video. If you have any query, you can ask in the comment section. Allah Hafiz.